Hello everyone, welcome back to my channel, and today our topic is X402 crypto payable system for the internet. So today we are not talking about another Web3 product and another token or another layer 2. We are talking about something much more fundamental. We are talking about how the internet itself never had a money built into it. How the X402 finally fixes that the protocol level, not the application level. X402 is not an app, is not an payment gateway, is a missing HTTP primitive revived using crypto. So why this all topic is matter? Bringing a native payment to HTTP 402 that HTTP gave us GET, POST 404 and 500, but that is never give us a payment. For 30 years, money lived outside the HTTP, like credit cards, Stripe, PayPal, subscriptions, logins, platforms. But X402 is a changes that. With X402, payment becomes a part of the HTTP request response cycle itself. This is a fundamental architecture shift. So why this topic is matter? Like internet had a native payment. First of all, the internet is defined for the share information, not for the exchange value. That's why every monetization layer is bolted on later. Every payment requires redirections to the another app, another systems like that. Every product needs account, sessions, KYC. This is not accidental. This is a protocol limitations. Then the subscription dominate. Like subscription exists because per using billing is too expensive. Credit cards can't handle micropayments. Payment APIs are stateful and complex. But subscription are bad UX. Like you pay even when you don't use. Creator lose casual users. And developer can't monetize small utilities. So developer want to pay per user. APIs are inherently usage based. Yet we build them monthly. That mismatch creates. Then overpayments, underutilization, piracy, API key leaks. The developer wants stateless per request payments. And the fourth one is like AI agents need autonomous payments. This is the critical. AI agents don't have email, don't have a credit cards, don't do the checkout flows, but they do the make API calls. If the AI is going to be anonymous, payment must be anonymous too. That X402 is built exactly for the future. This is the missing piece of HTTP 402. HTTP 402 has exists since 1996, but it was never implemented because there was no internet native money, there was no way to verify payment programmatically. Micropayments were impossible. Crypto changed all threes. Like now we have a stable coins, programmable signatures, global settlements. So X40 doesn't invent something new, it activates something that was always there. Confused about the what is the 402, we started talking about that, but like about all the requests, like a 200 is the code of requests. In the 200 that okay and successful means you are login or your payment done, then we can get that kind of response to 00. It's a 200 is a okay and successful. That 400 means a bad request, 401 means unauthorized, and the 402 is a payment required and reserved for the future use, originally intended for the digital payments. 403 means like forbidden that request, and 404 means like if you are going on any website and going somewhere and then you get a 404, if that website URL is not there, that page is not there, then we get a 404. That kind of request is a 402, also the one of them. So what is a X402? X402 is an open protocol that says like when server needs the payment, responds with the HTTP 402 and include a crypto payment interactions. Acceptors sign on-chain authorization delivered for the resources after verifications. And here's no need to, no sessions, no logins, no checkout page, just HTTP plus crypto, means USDC or anything like any payment system you want to add, then you can add that with the X402, HTTP 402 with that payment system. And that based on crypto as well, because that we have a virtual money like that. How that work, we can see here, user enter the credentials, browser do the initial request, then goes to server 401 unauthorized like www authenticated, and then prompt user for credential. They enter username and password, base 64 encode credential, of course that, and the authorization basic credentials. Then go for the verify payment, and the payment system is payment verified and 200 OK and access granted. So that way the 402 working. With the crypto, the components, the client can be the browser, the backend service, the script, an AI agent. Its only job that request response, sign payment when required, and retry request. Then the component 2 is a resource server. The server defines price, enforces the paywall, verifies payments, and delivers content. This is where your API or services lives. The component 3, facilitator. The facilitator verifies the cryptographic signature, settles the transactions on chains, and often pays for the gas fee. This keeps UX smooth and scalable. We can see here, the first is a client layer. Here the client layer, you can wallet, user and API agents. They request for the resource servers and service provider to verify, and the facilitator verifies and settlement payment, then settle, they goes to the resource layer and then access to the client layer. Then high level workflow, like client sends normal HTTP request, server replies with the 402 payment required, and that response included like amount, tokens, USDC, tokens means USDC or USDT or anything, any crypto tokens with the chain recipient address. That client signs the EIP 3009 authorization. That is a client signs Gasless payment with that EIP. Then client retries request with the X payment header. And the facilitator verifies that and server returns to the resources. Here's the topic about the server response with the HTTP 2402 payment required, indicating the payment is needed before the access. So here they do the respond. The client using the EIP 3009 gasless payment, which allows transaction without gas cost by having another party or a facilitator pay for the gas. The payment, instead of this, we are currently, or like before we use for the crypto payment, like crypto, any PayPal or any Google Pay, anything, like we have to integrate with that website. But here now, if you use this, then the user can pay via X402. The payment verification step ensures the transaction is valid before the resource delivery. And the resource is only returned after successful payment is done. So why the server returns 402? This is not an error. 402 is a protocol negotiation steps. It tells the client, I am willing to serve you at this price. This is extremely important for the machines. Some of the gasless payment with the EIP 3009. So what is this? Like traditional crypto payment failed because user must pay gas. Transactions are slow. UX is terrible. EIP 3009 fixes this with the flow, like user sign the message, facilitator submit the transactions, and the user pays zero gas. This is what X402 usable at a scale. Then the payment verification happen. In that payment verification, before delivering the resources, the server verifies the signature validity, amount correctness, and the nonce freshness, expiry time. So no payment, so no resources you get. This preserves the trust without custody. Then what makes 402 special? Let's be clear. Like X402 special because it is a protocol level. It's a protocol level. It's a stateless. It's a machine native. It's open. This is not a Stripe with the crypto. This is a HTTP with the money. So the real developer use cases and payment type, and why the X402. So AI interference with the payment type, we can like $0.01 per request. And in the X402 is a cheap and instant. API access per call, and there is a no Stripe. Content paywall is a per article or video. In here, the no subscription needed. IoT devices per usage, and here's the automated that. AI agents automatic, and here the no human needed. So AI API pay per interference, data API pay per query, content pay per articles, dev tools pay per executions, IoT machine-to-machine payment, and X402s unlock the market with the subscription kill. Here's the deep architecture of X402. There is a client SDK, browser and backend is there, facilitator, merchant executor, service and API, settlement contracts. So in the client layer, client SDK is there, browsers and backend integration is there, request handling and payment interface with the client layer. In facilitator layer, facilitator payment, verifications, transaction coordination and access control. In merchant layer, merchant executor, resource management, request processing, access control. In settlement layer, settlement contracts, smart contract logics, and payment settlement and transaction finality. Now the payment authorization with the EIP 3009. So now we are entering the most important technical part of the X402. This is the cryptographic heart of the entire system. X402 works because it does not require the user to send traditional on-chain transactions every time they want to pay. They would be slow, expensive, completely unusable micropayments or AI agents. Instead of X402 relies on the EIP 3009, which introduced something called transfer with authorization. Here's the what actually means the practice. Like instead of sending transaction, the user sends a cryptographic message. The message says that I authorize the transaction of that exact amount of USDC to this exact recipient within the exact time window and only once. So inside that signed message, several critical fields exist there. First is the amount. This prevents the server from the pulling from funds and then agreed. The authorization is exist, not up to, not approximately, but precisely defined. Second is the recipient address. Even if someone intercept the signatures, they cannot redirect funds to the another wallet. The signatures is bound for the single destination. Third is the validity window. This is the start time and the expiry time. After the expiry passes, the authorization cryptographically useless. This is the critical for the security automations. And fourth one is the nonce. This ensures that authorization can be used only once. Without this, replay attack is possible. Someone could reuse the same signed message multiple times. Now here's the key architectural insight. The user signs, but the server execute. The separation what enables like Gasless user experience, replay protections, and secure automation. The user never touches the gas. The server is a facilitator, submits the transaction on chain, and the blockchain enforces the rules. This is why the X402 works at internet scale. So what you need to build with the X402? This slide exists to kill a very common misunderstanding. When developers hear the crypto payments, they immediately assume complexity. Deploy contracts, minting tokens, managing liquidity, writing solidity. None of that required here. To build a X402, you do not need to deploy a single smart contract. You do not need to issue a token. You do not need to run complicated on-chain infrastructure. What you actually need to, shockingly simple. You need a normal runtime. Node.js, Burn, Next.js server. You need a wallet that can receive the USDC. You need a USDC balance. You need a access facilitator. And you need to X402 SDK. That's it. That is a deliberate. X402 is the design to feel like a web development, not a blockchain development. The blockchain is there for the settlement or trust, not for the developer frictions. Send the introducing X402 Starter Kit. This is where the theory becomes the real. The X402 Starter Kits created by the Denny exist for the reason to remove every possible excuse not to try this. Instead of spending weeks writing things together, the starter kit gives you the working reference implementation. It includes a server with X402 middleware already wired in, logic for payments and verifications, integration in a facilitator, and example premium endpoints that are the paywall by default. So this starter kit turns X402 from a concept into a something tangible. Here you can get the starter kit by the Danny. Then what is the structure of that starter kit? Let's break down why the starter kit is structured way like this way. First, there is a server. In the starter kits, this is the entry point of all the HTTP requests, and it doesn't care about the crypto at first, it just receives the traffic. Second, there is a middleware. This is the enforcement layer. It sits between the request and your business logic and decide its payment required for this endpoint or has it been satisfied. Third layer is merchant executor. This is the component is responsible for talking to facilitator, validating the authorizations and triggering the settlement. It isolates the payment logic from the application logic. Finally, there is an example services. So this represents the real product, an API call, an AI request, and dataset fetch. Notice something important here. The service itself has no idea that payment exists. That separation is intentional. X402 wraps the product, it does not pollute it. So how you can setting up the starter kit? You clone this repository, you install the dependency, and you copy the environment file. Inside the environment file configuration, you define the few things like a wallet address where payment should be sent, the blockchain network, and the API keys your premium services requires. You notice that most examples use the base Zapolia because base offers a low fees, fast confirmation, and the first class USDC support. For experimental and demos, this matters if you want developer focused on understanding the protocol, not fighting on a guest cost. So how the configuring the services? Now comes a powerful idea, pricing at the HTTP level. With X402, pricing is not abstract into a billing dashboards or a monthly plans. You can define prices per endpoints, per request, per even dynamically. For example, one API route might cost 1 cent, another might cost 10 cents. Another could depends on the compute usage or the data size. This aligns the prices actual resource consumptions, not arbitrary plans. So once you understand this, subscriptions start to look outdated. That kind of things you do the payment with the middleware. Then adding middleware, like adding middleware to your EAP. How that we can adding middleware to your API. Here's the core integration point. The middleware intercepts incoming requests before they reach your business logic. It checks it is a route protected, it is a payment attached, it is a payment valid. Its answer is, if the answer is no, the middleware responds with the HTTP 402 payment required. Nothing breaks, nothing crashes. The protocol simply pauses and asks for the payment. This is the heart of the X402 payment enforced and infrastructure, not application logic. Example of premium endpoints. How you can make a premium endpoint like this? Here's what the beautiful about the system. Your premium endpoints looks completely normal. It fetches data, it calls AI model, it returns JSON, there is no payment code inside it. That means your business logic stays clean, your testing stays simple, and your system stays maintainable. Payments wrap your API, they don't invade it. Then client request without payment. Now let's look developer experience from the client side. A client makes an HTTP request. They don't guess price. They don't prepay. They simply ask for the resources. Then the server responds with a 402, including the structured payment instruction. This is not an error. This is a negotiation. This client know exactly what is required to process. Like they know amount is this, currency in this, and this is the chain. Client paying 402. After receiving the 402 response in the before slide, the client signed the authorization. There is no need to guess, no transactions pop-ups, just a signature. The signed payload is injected into a request header, and the same request is retired. This is what a programmatic checkout actually looks like. Machines can do this, AI agent can do this, and the scripts can do this. Human don't need to be involved. Facilitator handling the payment. The facilitator is a silent workhorse. It verifies that signature is valid, that is the authorized hasn't expired, that is a nonce hasn't been used, and the amount is correct. Then it submits the transactions on chain and pays the gas. The design allows to X402 to scale without pushing complexity onto users. So if that allow all access and all things are done properly, then they go to next. And here's the payment settlement. Once settlement is happened, the rules are enforced by the blockchain itself. USDT moves from sender to recipient. The authorization is consumed. It cannot be reused. It cannot be reversed. It gives a finality, something traditional payment system struggles with. Like here you can see the request resources go to facilitator, then USDC payment required. If they transfer, then verify transfer by the merchant and confirm receipt and grant access. And there's a full end-to-end flow diagram. At this endpoint, it is important to walk through the entire workflow again slowly. That clients that request 402 responses, authorized signatures, client request is to the servers the payment verification, facilitator process payment, settlement confirm, and by the facilitator verify the payment, and the server deliver the resources. This is the payment flow cycle, and if the cycle repeats for the new request, and if not new request, then it's over here. Before we talking about the overview, we talk about common errors. Most issue is a developer hit predictable. An authorization might expire before its use. A nonce might be used accidentally. The user might have been enough USDC. The client might be on the wrong chain. And there are not protocol flaws, they are guardrails. Understanding them makes debugging straightforward. So here's the overview, like setup and running Facilitator, API with the paywall, wallet signing, successful payment unlock. After that, common errors. Most issues developer are the predictable, like an authorized might expire before its use. The nuns might be reused accidentally. The user might have enough USDC. The client might be on the wrong chain. This is not a protocol flaws, they are the guardrails. Understanding make them debugging and straightforward also. Like that kind of error, and we can fix with these things. 402 loop, then missing payment header, then the send auth with the fix there. Invalid signature with the wrong domain, check config. Payment failed, no USDC, then add the balance. What are the best practices for this? In production, a few rules matter. Always use stable coins. Volatility kills UX. Catch valid authorizations to reduce overheads. Log every verifications and settlement. Validate expiry strictly. This practice turn into proper X402 system. What are the future of X402 success? Now zoom out, like if X402 succeeds payment, stop being payment and start being protocols. Browser could natively understand the 402. AI agents could operate entire business autonomously. Paywall could be open, composable and permissionless. Stripe and PayPal would become optional, not mandatory. This is not an incremental improvement. This is the architectural evolutions of internet. Now we understand about the 402. So here's some of the summary. Like X402 turns HTTP 402 into real on-chain payment. Gasless USDC authorized, easy to devs for the middleware, perfect AI API billings. Starter Kit makes integration simple. So the X402 is not trying to replace the Stripe, PayPal or any subscriptions overnight. It is fixing something much more fundamental. For the first time, the internet has native way to ask the payment, verify it programmably, and deliver value instantly, without accounts, without frictions, and without intermediators. HTTP 402 exists almost 30 years. Crypto finally made it possible to use. If you are building API, AI services, or any system where usage matters, X402 is the not optional knowledge anymore. It's a new primitive, not a product, not a platform, infrastructures. That's it. You can use X402 for your app and you can make a good product with that. So goodbye everyone. Here's our X402 is complete. We meet again with the new technical concept.